For this video, we're going to be discussing translating verbal arguments into symbolic form. So what we're going to be talking about is we're going to be talking about taking our arguments, our logical arguments that are in verbal form, and using some mathematical symbols to represent them in a symbolic shorthand. So if we take a look, here are some symbols that we're going to be using. We've got a single direction arrow, a line with two arrows, these three dots, this kind of up caret, this down caret, and this squiggly thing. All right, and these are going to be our logic symbols that we use. And we've already seen some of these, but let's go through them. So you should recognize this arrow. That arrow stands for implies or if then. Meaning if I've said, for example, P implies Q, or P arrow Q, that's P implies Q. Or if P, then Q. So the arrow is an if then. The double arrow is an if and only if statement, or remember we called this a biconditional. So the double arrow means if and only if. The three dots means therefore, like this is true and this is true, so therefore something else is true. Okay. Our up caret means and there shouldn't be a y in here. If for math, when we're talking about and, both things must be true. So if I'm using this arrow, I'm saying in order for something to be true, both this and this must be true. Right? And means both must be true. The down means or, and for or, only one of them must be true. And our squiggly line means not. All right, so these are the symbols that we're going to be using. And we can use these symbols to translate. So we can use the symbols to translate verbal arguments into symbolic form. For example, if we let P be, it is cloudy, and Q be, it might rain, the statement, if it is cloudy, then it might be rain, can be represented as P arrow Q. All right, P being it's cloudy, Q being it might rain, and the arrow meaning implies or if then. All right, so it's simple. We just take the words and turn them into symbols. So let's take a look at an example. Here's example 1. It says let P be a shape is a triangle, and QB the shape has 3 sides. We want to translate this argument into symbolic form. So what I want to do is I want to take this argument here, and I want to take each line of the argument and make it symbolic. So if I look, I've got if a shape is a triangle, then it has 3 sides. Well, we know shape is a triangle. That's P. Having 3 sides, that's Q. And I've got if and then, which I know is represented by an arrow. So this first line can just be represented as, I don't know what just happened there. That first line can just be represented as P arrow Q. If P, then Q. All right. My next line says a shape is a triangle. Well, I know that's just P. So my next line is just P. And my third line is therefore. Remember, therefore is my 3 dots. And it has 3 sides. That's Q. So my next line is therefore Q. All right, my 3 dots and then Q. So this is the symbolic version of this argument. We're saying if P, then Q, P, therefore Q. P implies Q, P is true, therefore Q is true. All right, we're just taking this verbal argument and representing it symbolically. All right, let's take a look at another example. This example says, a shape has 4 right angles, or let M be a shape has 4 right angles, and N be a shape is a rectangle. I want to translate this symbolic statement into verbal form. So this is a little different. Okay? So let's see what we've got here. We're saying we've got n arrow n. So this is saying if n, then m, right? Well, we know n is a shape is a rectangle. So I could say if a shape is a rectangle, I know m is the shape has 4 sides. So I can say, or I'm sorry, shape has 4 right angles. So this statement here, n arrow m, is if a shape is a rectangle, then it has 4 right angles. That's the symbolic representation of this sentence. Okay, well, let's go down to the next one. We know this squiggly line, it's called a tilde. T-I-L-D-E. That's what this squiggly thing is. Okay, this means not. So we're saying not n. Well, n is a rectangle, or n is a shape is a rectangle, so not n is a shape is not a rectangle. Well, what does that imply? Well, I've got my 3 dots. That's therefore not m. So therefore, it does not have 4 right angles. So if I read this, I say, well, n implies m. If n, then m. If a shape is a rectangle, then it has 4 sides. Not n, a shape is not a rectangle. Therefore, not m. Therefore, it does not have 4 right angles. So all I did is I took my symbolic argument and made it into my verbal argument. Let's take a look at another example. This one is a little bit more confusing, but let's see what we got. We've got P is a number is an irrational number, and Q is a number is a terminating decimal, and R is a number is a repeating decimal. And I want to translate the following symbolic argument into verbal form. So this one's really weird looking. Let's see what we can do here. I've got not Q and not R implies P. Okay, well, this is saying not Q, a number is not a terminating decimal, and not R, a number is not a repeating decimal, implies P, a number is an irrational number. So I can say, if a number is not a terminating decimal and not a repeating decimal, that's this part here, not Q and not R, then it is an irrational number. So that's what this little symbolic sentence says. Not Q is if a number is not a terminating decimal, and not R is not a repeating decimal, then, this is the if-then symbol, it is an irrational number. I know that looks really confusing, but if you take it step by step, you can get this sentence. Next step is just R. A number is a repeating decimal. Now, remember, and means they both have to be true. And so both not Q and not R have to be true. But then I'm saying R is true. Well, not R and R can't both be true. A number can't be both repeating and non-repeating. So what's the end of my argument? Therefore, not P. Therefore, the number is not an irrational number. All we're doing is translating these symbols into sentences. Okay, let's take a look at another one. Example 4 says, you run out of gas. Let A be you run out of gas. Let B be that your car breaks down. And let C be you make it to your destination. And I want to translate this verbal argument into symbolic form. Okay, let's see what happens. It says, if you run out of gas or your car breaks down. Well, let's go out through this. Run out of gas, that's A. Or, that's this upside down sort of V shape. Your car breaks down, that's B. Then, so I've got if, then, that's an arrow. You do not make it to your destination. Well, C is you make it to your destination, so you do not make it to your destination, that's not C. So if I look at that in our symbolic form, I get well, this is all screwy looking. A or B implies not C. I've got A, I've got or, I've got B, implies, and this is do not make it to your destination, that's not C. So A or B implies not C. Okay, my next statement says you run out of gas. Well, that's just A. So therefore, you do not make it to your destination. That's therefore, you do not make it to your destination, not C. So, not C. There we go. A implies A or B implies not C. I've got A, so I have not C. I could also have B here, and this would still be true. All right, so we just translated from verbal to symbolic. So now you've seen how to do this. Your try it problem for tonight is if you let P be, you score above a 90 on a test, and Q be, you earn an A, I would like you to translate the following verbal argument into symbolic form. If you score a 90 on a test, you earn an A. You did not earn an A, therefore you did not score above a 90 on the test. This is your video, or this is your question you need to do for the try it problem.